We will discuss the timing diagram of 8086 read machine cycle in minimum mode. This timing diagram shows the bus activities during the read operation. One cycle of the clock is called state or T state. A state is measured from the falling edge of one clock pulse to the falling edge of the next clock pulse. A basic microprocessor operation such as reading or writing a byte to memory or I/O device is called a machine cycle. A machine cycle consists of several T states. The time a microprocessor requires to fetch and execute an entire instruction is referred to as instruction cycle. An instruction cycle consists of one or more machine cycles. This is the timing diagram of 8086 read operation in minimum mode. To perform a read operation, the CPU has to generate ALE, MOR IO bar, address and status signals, BHE bar, then wait for the device ready, then read signal, data enable, data transmit or receive. There are 4 T states including a wait state for this read operation. During the first T state, CPU asserts ALE. It indicates the multiplexed address status and address data lines carry valid address. See here, from this point onwards, this address status lines carry valid address. The CPU also asserted BHE bar. Multiplex address data lines will carry valid address. And after that, AD0 to AD15 is reserved for data. Then address status lines, after this point, they will be carrying status information. MOR IO bar, this will be high if it is a memory read, it will be 0 if it is IO read. This means the signal is valid from this point and it will remain valid till this point. Its value is 1 or 0. 1 means memory operation, 0 means IO related operation. The device is becoming ready near the end of third T state. So the CPU has to put some wait state. CPU asserts read signal near the end of second T state. When the device is ready and read signal is active, valid data appears on the multiplex address and data lines. Data enable is active from this point onwards and it becomes inactive at this point. DT or R bar, data transmission or data receive. This signal is active at this point and will remain active up to this point. This will be as 1 if CPU is transmitting data, it will be 0 if CPU is reading data.